Hello guys, welcome to Long Thinking. Today I will show how to do structure analysis of a simply supported beam in HyperMesh. For this, I have a small example. You can see we have a simply supported beam having a length 200 mm and a point load exact like middle 20,000 Newton. The cross section is rectangle and the dimensions are 20 mm into 20 mm. I'm using this 210 gigapascal material in modulus. So I have calculated the deflection and bending stress from formulas. I am getting around 1.2 mm deflection. And the bending stress is around 75 megapascals. So I will give the same things in HyperMesh and I will see the results. Then we will compare the results. So the main motto of creating this video is there is no perfect video on simple supported beam. So I'm trying to show this and you may get to know how this analysis. So now we'll move to HyperMesh. And the first thing you need to be in Sketch, and only two browsers should be there. One is session and one is model browser. And the file follower interface should be Altair HyperMesh. Now if you doesn't find this model browser, go to view here and click on this model browser. You will find the model browser. So now on this model browser, I will click on right click and I will create a material, or else I will import from here model. Fine. Time being I'm selecting from here. So make this as steel name and move your cursor EG new and RHO. You will get some values. You just confirm those values because we are giving the same values. If you want use any another material, you should give other values. Let's close these things and we have created a material. We need a line because a beam is always a 1D element. So I'm selecting stop view and I will select this plane and make this as 0 and I will create plane and I will select this line. I will draw like this and I will select the dimension and I will give dimension as 200 mm. So I will make from here to here, it would be around 100 mm. So now our sketch has been done. Before that, we have to create a small point at here, at exactly at middle, because we can see the node easily. Go to topology, select here, create point or node, no problem. You can see it is showing middle. Select this middle and you can just click on enter and you can exit from here. So now I will go to 1D now. We have given the length, but we have to give the section for this beam. Select the beam section here and make this as standard and this should be bar. And the dimension of this is 20 mm and 20 mm. So now you can see the centroid moment of inertia has been calculated. Just close this one, the section has been created. Then we have to create a property, create property, and it should be P beam L. You can see P beam and P beam L. So I shown the difference in my last video. You can see my last video and you can find. For time being, I'm giving P beam L. The material should be which we have created. The section should be which we have created. Just close this one. Our property has been done. Now go to components here and select this line and make this property as which we have created. So now everything has been set. We need to mesh this one. Select the line mesh and select this one and edit element category should be beam, and the properties should be this one, and you can see I have given the beam and the property, and I will close this one, and I will give the element size as 4 or 5. Everything is fine, anything is fine. We'll give 4 now. Enter. You can see that small nodes has been created, and click on right button here. So now we have given the mesh, and we have to analyze this one. Go to analyze tab and give boundary condition, left constraint and the right constraint, as well as a load. Select the constraints option and select this node, select the tick mark, and here for simply supported beam, the first 3 should be arrested. Remaining 3 should be free, because the translation along X, Y, Z direction should be arrested for the hinged support. The rotation is allowed. In some softwares, they may allow only in Z directions, but in HyperMesh, we should free all these 3 rotations to create. You can see a small triangle has been created. So now the same way we have to give here a roller support. Select this constraint and select this one and remove this one. The rotation is allowed, as well as the X direction should be allowed. And select this node and select the tick mark. Create. Here also it has been created. Now close this one, and we will apply a load exactly at here. Select load here, point load, and select this node, exactly the point we have created. And select the tick mark. Here only the y axis should be 1, remaining should be 0, because we are giving load in y direction. Make this as 20,000. You can see the 20,000, right? And create. Then close. The load has been created exactly at middle. So after this, we have to create a load step. Click on model browser, right click, create a load step. Make this as linear static, and SPC should be this one. Okay. Then this one. Again, confirm this one. Then okay. Then close this one. Then we have to go to Analyze tab. Click on the Analyze button, and we have to give the name beam underscore simply supported beam, and save this one. It will ask like this: give all, standard, preserve, and export. The solver OptiSoc solver will solve, and it will give the pop-up. Select the run option. So it will give message analysis completed. Click on the results. So now select this contour. We are in hyperview now. Select this contour, displacement, mag, and click on apply here. So now you can see the deflection, maximum deflection, 1.2, 10 to the power of 0. That means 1.2 mm. If you want to see this in y direction, it may come in negative direction. You can see that minus 1.2, because it is acting in downwards. So it should be minus 1.2. So the maximum deflection is 1.22. In our calculations, we are getting 1.2. So deflection is okay. Then we have to see the von Mises stresses. Click on apply. You can see we are getting 7.5 10 to the power of 2. Then this should be 75 megapascals. And one important thing I forgot to tell is, if you want to see this in 3D, just click here and make this as like this. You can see the 3D. If you don't want, you can just select this one. So now we will push it with results. So this is our results. You want to see this from top view. You want to see the animation because it's very small deformation. You may not found the uh, animation clearly. We have to give the deformation apply. So now it has been applied. We want to click on this play button, then visualize this one. This should be like this. Maybe you can see clearly. So this is how the simply support with deform, and we are getting the stress. In my last video, I have shown you how to generate shear force and bending moment diagrams in HyperMesh from bar plot. If you are interested, you can go to my last video cantilever beam and you can visit those. That's all for today. I have shown the comparison with my calculations as well as the animations and all those things. So hope this video might be helpful for you. So if you want interesting videos like this, please do subscribe, give a thumbs up. Thank you.